Good afternoon. My name is Christian Hansmann. I'm from Woodkeplus, and today I would like to present some investigations on the self-ignition of solid wood, which we started recently. Building and insulation materials made from renewable raw materials relieve the environment and are becoming increasingly popular. This development must also be considered accordingly in fire protection. However, the ignition and fire behavior of wood is very complex. The ignition point of wood above 330 degrees Celsius, which is generally accepted in wood technology, only applies to a relatively short temperature exposure on thermally uninsulated sample. There are indications in the literature that significantly lower temperatures can lead to spontaneous combustion of wood. However, the number of studies on this subject is very small, and informative publications have been published decades ago. This has motivated us to take a closer look at this topic. The fire triangle illustrates the three elements a fire needs to ignite. In contrast to piloted ignition, where an external flame is needed, the auto-ignition temperature of a substance is the lowest temperature at which it spontaneously ignites in normal atmosphere without an external source of ignition. Regarding wood, we have to distinguish between glowing ignition with lower temperature in comparison to volatile ignition with a hot flame. Our approach is to look at small homogeneous samples and transfer findings to the bigger scale and vice versa. So what was done? On the small scale, simultaneous thermal analysis was performed on the three main substances of wood as well as different blends and thin spruce veneer discs. On the bigger scale, we performed furnace experiments. The aim was to see the influence of the size and external temperature on the heating and subsequent combustion of wood. A special rig fitted with thermocouples was built to place 4 cubes of wood at the same time in a preheated furnace under isothermal conditions. An example of a wood thermogram. You can see a two-step disintegration due to the separate destruction of the components. During the first mass loss, we have devolatilizations and pyrolysis, followed by the oxidation of leftover charcoal and lignin. We can attribute the mass losses of the different temperature to the pure substances. Here we see example temperature curves from the Mafro furnace experiments. One diagram for each of the 5 isothermal furnace temperatures and the color code for the different sample sizes. At 240 degrees Celsius, none of the cubes ignited, but slight exothermal behavior can be seen in the case of 15 and 20 millimeter cubes. This is also confirmed by the residual charcoal reproduced at these temperatures, while with other temperatures, most of the samples are burned without any leftovers. With increase in size, the probability to ignite and burn out rises. Also, the change in reaction time, heating till furnace, but also the time till it is burned out, can be seen here. Here, the duration of the exothermic reaction is displayed. A rise in temperature leads to higher heating rates in the cubes and to a faster heat transfer, and overall to faster reactions. The size dependence can be seen clearly. Also regarding the reached maximum temperature. We can conclude that auto-ignition is dependent on the size, at least in the analyzed range. We need enough volatiles in short time to ignite or enough charcoal surface for glowing ignition. The comparison of furnace temperature and SDA thermograms reveals that 360 degrees Celsius isotherms seem to be related to the pyrolysis of hollow cellulose. But the research on ignition, of course, is far from over, and we will continue to study this topic, also for the knowledge-based development of fire retardants. We will expand our equipment in the next time and are, of course, looking forward to possible cooperation in this area. Finally, I would like to thank my team regarding the fire behavior for the good cooperation, and special thanks to Andrea and Vicky and their teams for organizing this conference despite all the circumstances. We all would have loved to come to Porto Roche. Hopefully we can make up for it soon. I'll be happy to answer any questions if I can. And so I thank everybody for your attention.